Greetings, my humans. How's everybody doing? Let's learn about solving absolute value equations. So, an absolute value equation is simply an equation that has an absolute value expression. So, in order to be an absolute value equation, it needs absolute values with a variable inside. Here's a few examples. Absolute value of x equals 2, absolute value of x plus 1 equals 5, 3 times the absolute value of 2x plus 1 equals 6. We can solve these types of equations by solving two related linear equations. So if you have the absolute value of some expression ax plus b equal to some number c is greater than or equal to 0, you can split that into the related equations where the ax plus b that was inside the absolute value, you got one equation where that equals c and one equation where that equals negative c. So a couple things to notice about this. The absolute value part has to be isolated, which means it's the absolute value is all by itself on one side of the equal sign before we can split it into the two related equations. Another thing to remember is that the number c that the absolute value is equal to can't be negative. The reason is because absolute values can't be negative. And the related equations down here, you need to notice that the absolute value symbols are gone now. Once we split this into the two related equations, that's how we get rid of the absolute values. All right, let's see how we're going to solve this. Here we've got an absolute value. The absolute value is all isolated on one side of the equal sign. The other side is equal to a positive number. So, since it's equal to a positive number and the absolute value is by itself, we can write our two related equations. So the inside, x minus 4, the one equation is where it equals 6. The other equation is where it equals negative 6. Notice that the inside, the x minus 4, is the same in both. We don't change the signs on what's inside the absolute value. We only change the sign of the number it's equal to when we set up our related equations. Well, to get x by itself, to isolate x, we would need to add 4 to both sides of this equation. Same thing over here, we would need to add 4. So we add 4 everywhere. 6 plus 4 is 10. Negative 6 plus 4 will give us negative 2. So we get x equals 10 or x equals negative 2. And those are our solutions because the x is by itself now. And then you notice it says to graph the solutions. Well, since we only have a single variable x, we can only graph on a single number line. So the graph would look like this. You got a number line, here's negative 2, you just put a dot at negative 2, a dot at 10, and those are the two solutions. Then notice that each solution here is 6 units away from 4. 4 is this number in the middle, and each solution is 6 units away. And look how these numbers work out, right? X minus 4 equals 6. So 4 is like this target number in the middle, and 6 is the distance away. So that's kind of a cool thing. Okay, how about this equation? Here we've got an absolute value. It's all isolated by itself, equal to, a negative number. Is that okay? Absolute value equal to a negative? No. So the absolute value expression has to be equal to 0 or greater. So the absolute value of 3x plus 1 can't equal negative 5 because you take the absolute value of anything, it can't be negative. So that means that this equation has no solution. There's no number you could put in for x that would make the absolute value of 3x plus 1 equal negative 5 because absolute values can't be negative. Okay, let's look at some practice problems. First, we've got absolute value of x equals 10. The absolute value is already isolated, and it's equal to a positive number, so we can rewrite with our two related linear equations, one where the inside equals 10 and one where the inside equals negative 10. So we got x equals 10 or x equals negative 10. Since in this equation, the only thing inside the absolute value was x, we don't have to do anything to isolate x now in our two equations here. X is already isolated, so we're done solving. So the solutions are 10 and negative 10. Number 2, we've got absolute value isolated by itself equal to a positive number. So that means we can write our two related linear equations. One where the inside equals 4, one where the inside equals negative 4. So x minus 1 equals 4, or x minus 1 equals negative 4. Now we still want to get x by itself, and in order to isolate, we're going to have to get rid of this minus 1. So we're going to add 1 to each side of the equation, and we'll do that to both equations. So 4 plus 1 is 5, so we get x equals 5, or negative 4 plus 1 is negative 3. So we get x equals 5 or x equals negative 3, and our x is isolated, so we are done solving. Number 3, we've got an absolute value. It's all by itself isolated, but it's equal to a negative number. Uh-oh. Absolute value is by itself, but it equals a negative number. Absolute value cannot equal negative, so this puppy has no solution. Sad. All right. Number 4, we got the absolute value of 4x minus 5 equals 8. We've got the absolute value all isolated, and it's equal to a positive number, so we can rewrite this as our two related linear equations. So we got the inside equal to 8, so 4x minus 5 equals 8, or the inside equals negative 8. 4x minus 5 equals negative 8. Now, we're just going to use our normal algebra solving procedure. Get rid of the minus 5 by adding 5 to both sides. So we'll get 4x equals 13, and over here we'll get 4x equals negative 3. Now we just need to divide both sides by 4. And if we don't get something that goes in easily, we just leave it as a fraction and reduce. So first we get x equals 13/4, or x equals negative 3/4. The x is by itself. We can't simplify or reduce those fractions any, so we're done solving. All right, here comes example 2. An instinct might be to say, oh, we have an absolute value equal to a negative, so no solution. But the problem is our absolute value isn't by itself yet. So the first thing that we're going to need to do is get the absolute value by itself. We need to get rid of this minus 10, so we're going to add 10 to each side of the equation. And that gives us the absolute value of 3x plus 9 equals 6. We've got absolute value by itself equal to a positive number. So we can split that into the two related equations. So there will be one equation where the inside equals 6, and one equation where the inside equals negative 6. We're going to need to, in order to solve for x, we're going to have to subtract 9 from both sides on both equations. And then we're going to have to divide both sides by 3 on both equations. And we get our solutions x equals negative 1 or x equals negative 5. Now we are going to look at problems where they give us two solutions and we are supposed to write the absolute value equation that has those two solutions. So the first thing that we're going to do is find the number that's halfway between the two solutions. And you can do that by adding them together and dividing by 2. Then we're going to find the distance from the halfway point to one of the solutions. It'll be the same in either direction. And then we will write the equation like this. We got those two numbers, the halfway point and then the distance away from the halfway point. And so the way we build the equation is the absolute value of x minus the halfway point equals the distance from the halfway point. this will hopefully make sense as we do an example or so. So in a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of the routine is 5 minutes. Write an absolute value equation that has these minimum and maximum lengths as its solutions. All right, so the two numbers are 4 and 5. So the first step would be to graph them on a number line and then find the point that's halfway in between them. If we were to add 4 and 5 together and then divide by 2, 4 plus 5 is 9. 9 divided by 2 is 4.5. So the halfway point is 4.5, and the distance from the halfway point to either solution is 0.5. So 4.5 plus 0.5 takes you to 5, and if you take away 0.5, you're down to 4. So the distance away is 0.5, and the center point, or the halfway point, is 4.5. Then we just plug those numbers in the right place. Absolute value of x minus the halfway point is equal to the distance from the halfway point. So that is how we do it. And that's that, folks. Make sure you got really good notes.